I'm starting out this problem by recording what I originally started with in Mat A, what I originally started with in Mat B. Now that I've done that, I'm going to begin simplifying by making zeros. If I have a positive and a negative unit, I know that that gives me 0. I know down here my negative 1 and my positive 1 also give me zeros. So now instead of having 3 plus a negative 2, I have 3x left plus 1. On Mat B, there's nothing I can simplify to make zeros. Now that I've simplified all the zeros, I'm going to see what I can add or take away from both sides to help me simplify further. On Mat B, I have an x I'm going to get rid of, so I'm going to take away an x. I'm going to do the exact same thing in Mat A. Also, in Mat 1, I have a positive 1 I'm going to remove. In Mat B, I have a positive 1 that I'm going to remove. What I'm left with is 3x, and then on the other side, I'm left with 6. When I'm taking a look at 3x plus 6, I don't know which is greater because it really depends on how much x equals. So I'm going to have to write a question mark for that one. I can go back and determine some amounts for x, and depending on what that is, it will let me know if my expression is greater than, equal to, or less than. So if I'm going to make it equal to, 3x is equal to 6, I know that x would have to equal 2. And I can check my work by showing 3 times 2 equals 6. If my number is, if x is less than 2, so maybe x equals 1, I can go through and solve 3 times x, which is now 3 times 1, compared to 6. We know that 3 is less than 6. So any number, you could choose a negative, 1.9, any number less than 2, you're going to get Mat B being more. If I wanted it to be greater than that, I can choose a number greater than 2, and I'm just going to choose x equals 5. And I can prove my work. 3 times 5 compared to 6, going to go through and revise that. I know that 15 is greater than 6. You can have a wide variety of answers. These are just a few examples.